So let's take a look at polymerization. This is a type of alkene reactions, probably the most important types, in which we actually make plastics. So when you say polymers, you're thinking plastics, even certain types of glues, Kevlar, etc. We're talking about polymers. Basically, for polymers now, I need high temperature and pressure with a catalyst. And polymer means many. So I start off with a monomer. And then I go to a polymer. Again, think of plastics when you're doing it. Let's show how polyethylene is made. So polyethylene is like in plastic bottles and stuff. With that, we start off with the monomer, which is going to be this molecule right here. This is actually, technically, it's ethene, but everybody calls it ethylene. That's the common name for that. And so what happens is, this is like we did with addition reactions for alkenes. I'm going to break apart the double bond into single bonds, and then I'm going to add these units across it. A couple of things when I'm doing this. I'm going to go ahead and redraw this so that the hydrogens step up and down. It's going to be a bit easier to do that. So whenever I do that, I redraw this, so the hydrogens go straight up and down. I'm going to break apart the double bond, and then I form two single bonds. I'm going to draw the single bonds on either end. So this right here is the monomer. So again, you have high temperature and pressure, etc. It's going to break this apart. And I form these two single bonds on either end. So this was carbon number 1 and 2. So 1 and 2. Now what happens is, in this case now, another one of these units is going to bond to it. So you have all of these bond to it. In fact, you can have up to 1,000 of these units bond together with this. So that's just called a monomer. So I'm going to draw another one with that. There's one on this side too. So basically, this one right here is going to repeat itself throughout. Again, that end now can be up to 1,000. It just depends how many that you want. But it's no different than the addition reactions. I break apart that double bond, and then I form two single bonds on either end, and then they kind of linked up with that. So this will be the monomer, this will be ethylene, and then this will be the polyethylene. And then you can control how many units that you want, etc. Let's do another one. Let's look at styrene here. So a couple of things. It's drawn like this to get the right angles, but then I'm going to redraw this so that everything is up and down to make it easier for us to see. So this is styrene. So again, make polystyrene. You can make plastics, even styrofoam from this. So I'm going to heat it up, high pressures, etc. I break apart these double bonds now, and I form two single bonds. And then what happens is, this is a monomer. That unit repeats itself throughout. And again, notice it goes in a very particular order. Hydrogen and styrene, hydrogen, styrene, hydrogen, styrene. So again, it repeats itself throughout, and then you end up with polystyrene. You can actually use that to make styrofoam with that. Let's do one more with these polymers. So say, let's look how they make Teflon, the nonstick. So it's actually tetrafluoroethane. Again, what we're going to do is we're going to break this apart, and we're going to draw these fluorines up and down with this. So let's go ahead and do that. Draw two bonds on either one of these carbons here. And then we just add the other units as we do correspondingly for this. So again, that endings, I can repeat this as many times as you want. This right here, the way I drew it, just for technically, this is called 3 units. But then in real life, you can have up to 1,000. Again, the more units that you link up, the different the properties of the plastics are going to be, etc.